Have you ever looked up at the night sky and thought, this neighborhood is just a little too quiet? Well, welcome to today's Explainer. We're heading straight to the Galactic Center. We're going to explore what happens when moving the entire solar system becomes a reality. Now, currently, our solar system is tucked away in this pretty boring suburban spiral arm of the Milky Way. I mean, it's safe, sure, but it's kind of dull. So today we're exploring a completely wild premise. What if we packed up our quiet little cosmic neighborhood for a front row seat to the very heart of the galaxy? Okay, let's dive into this. What if we moved our solar system? And to be clear, I'm not just talking about sending a probe or, a little exploratory fleet. I want you to imagine literally packing up the sun, the Earth, all the other planets, and every single asteroid in our neighborhood and physically relocating the whole shebang. We are talking about the ultimate cosmic road trip right to the center of our galactic home. And just how far is this road trip? Well, 26,000. That is the absolutely staggering scale of our journey. We are moving exactly 26,000 light years inward. Just to put that into perspective for a second, even if we were traveling at the absolute maximum speed limit of the universe, the speed of light, it would still take us 26 millennia to get there. We're journeying from the quiet, lonely fringes of the Milky Way straight into the bustling, chaotic, and unimaginably dense center of our galaxy. So why would we even attempt something so absurd? Well, some might say the view is literally to die for. Aside from getting the ultimate bragging rights of living right next door to a 4 million solar mass singularity, the scenery change would be immediate and absolutely breathtaking. But I really want to emphasize the word literally here, because while the view would be spectacular, pulling up stakes and moving next to a supermassive black hole comes with some immediate terrifying consequences. And this brilliantly illustrates the sheer contrast between our current home and our destination. It's staggering. Currently, in our quiet suburbs, our closest stellar neighbor is Proxima Centauri, sitting a lonely 4 light-years away. Our night skies are dark, they're vast and peaceful. Now imagine the core. Down there, stars aren't light-years apart. They are packed so tightly together, they're mere light weeks or even light days apart. The ambient starlight in the sky would be so incredibly bright, glowing literally like a sky full of full moons, that you could actually sit outside and read a book at midnight. It sounds majestic, right? But as we're going to see, that crowded sky is just the beginning of a cosmic nightmare. So before we even deal with the nightmare waiting at the destination, we have a massive logistical problem. How do we actually move a star? How could humanity possibly steer the entire solar system? Because remember, it's like a giant puzzle. If the sun moves, its gravity pulls all of us along with it. So we need a way to build a cosmic engine big enough to push our entire solar neighborhood 26,000 light-years across the void. The theoretical answer to this is called a Shkadov thruster. This is a hypothetical megastructure. Imagine a giant parabolic mirror built out in space. The whole concept is that this incredibly massive mirror sits on just one side of the sun and reflects the star's own radiation back at itself to create a tiny but continuous amount of thrust. It's essentially the ultimate solar sail. But because the thrust is so minimal compared to the massive, massive weight of the sun, we certainly wouldn't be traveling at warp speed. It would take millions of years of just slowly, gently sailing through the cosmos to finally reach the center. Let's move to and see how this builds, because a multi-million-year journey through an increasingly dense galaxy is not exactly what you'd call a smooth ride. At the 1 million-year mark, we cruise past the ominously named Great Annihilator, which is this powerful source of antimatter. Yikes. By 2 million years, we are plunging straight through the incredibly dense, highly active molecular clouds of the inner galaxy. And at 3 million years, we are encountering entire clusters of supernovae. You see, the closer we get to the center, the more crowded it becomes, which means stars are living and violently dying right on our front doorstep. And that brings us to the visceral, immediate danger of the journey itself. Earth's ozone layer, that could be completely stripped in an afternoon. The ambient radiation levels as we push through these dense clusters of exploding stars are absolutely off the charts. Literally, one nearby stellar blast would completely fry our protective atmosphere. To even survive the transit to the galactic center, humanity would have to completely relocate into deep underground bunkers, or we'd have to somehow engineer a massive planetary-scale radiation shield. But let's say we do it. We survive the millions of years in transit, we survive the insane radiation, and we finally arrive. We are meeting the beast, Sagittarius A star. We managed to park our solar system in orbit just outside the event horizon, and the visual from Earth, wow, it is terrifyingly beautiful. You wouldn't just see a black void up in the sky. Instead, you'd be looking up at the accretion disk. This is a swirling, glowing whirlpool of superheated gas and dust, and it's spinning at a fraction of the speed of light. It would look like a massive golden halo of fire stretching across half of our entire sky. But that incredible beauty is a trap. The gravity at the galactic center is a complete and utter mess. First of all, you have these massive S-stars traveling at millions of miles per hour, zipping around the black hole like a swarm of angry bees. Because of all these incredibly massive objects and the black hole's own intense gravity, Earth's orbit around the sun would be constantly tugged, stretched, and warped. The gravitational tidal forces would almost certainly rip the Earth entirely away from the sun. We'd find ourselves transformed into a rogue planet, ripped from our star, just drifting alone in the dark through the most violent, chaotic part of the entire galaxy. And believe it or not, the physical destruction isn't even the weirdest part of this whole thought experiment. Now we have to talk about the gravity time warp. When you park a planet this incredibly close to a supermassive black hole, you are sitting deep, deep inside a massive gravitational well. And according to Einstein's theory of relativity, extreme gravity doesn't just bend space, it literally bends time itself. Now, what's really interesting about this slide is how that mind-bending physics plays out. Time literally works differently for us than it does for the rest of the galaxy. Just 1 year spent living at Sagittarius A star would equal decades or even centuries back out in the spiral arms. If we stayed parked near the black hole for just a single year and then somehow managed to pack up and travel back to our original spot, everyone we ever knew and many generations after them would be long gone. We would be literal cosmic time travelers, but with absolutely no home to return to. So, to quickly sum up our ultimate destination, the drawbacks to this prime galactic real estate are, well, massive. You've got lethal, constant X-ray radiation bombarding the planet. You have the ever-present, terrifying risk of making a slight orbital miscalculation and being completely swallowed by the singularity. And with thousands of massive stars flying around us in this chaotic, unpredictable dance, a passing star could easily just slingshot Jupiter out into deep space, completely destabilizing the orbits of whatever is left of our entire solar system. So the crucial point is this. The galactic suburbs are exactly why we're alive. The fact that we are sitting right here in a boring, quiet spiral arm 26,000 light years away from all of that action is the sole reason humanity survives to even talk about this. The extreme radiation-soaked, gravity-warped environment of the galactic core is simply incompatible with life as we know it. We completely owe our existence to the quiet suburbs. Which brings me to a final question for you to ponder. Where would you live in the universe? Let's say you had the advanced technology to actually survive it. Would you brave the incredible dangers of a supermassive black hole just to see that magnificent golden halo of fire in the sky? Or would you seek out a nice, quiet, colorful nebula somewhere far away to call home? Let me know what you think. And if you enjoyed diving into this hypothetical journey with me in this explainer, please leave a like and subscribe for more deep space what-ifs. It really helps us out, and I absolutely cannot wait to share our next topic with you. Keep looking up, and I'll see you next time.